All right, I'm only going to cover 2 examples for 6-6 graphing a system. So basically, you just graph 2 of them on one, and you see where they overlap. So here we go. Let's graph the first one here. We have a y is less than 2x minus 3. So that's our y-intercept of minus 3. Okay, and then if we have a slope of 2x, we're going to go 1 to the right, up 2. Okay, so make sure you're careful. Again, follow your first step. First step, where does it go? Second step, what does it look like? This one's going to be a dashed line because of the symbol. Okay, so I'm going to make little dashes and my dots here. Again, make sure you're careful. Don't graph a solid line too soon when it should have been a dashed line to begin with. All right, so we got to graph the less than side. So y is less than. So very lightly, I'm going to graph the less than side. I'm not going to get it too dark because I don't know what the other one's going to look like yet, and I don't want to goof up all the quarter points and I can't see it. Another method is there's some people that even just write arrows. Okay, so hey, eventually I'm going to graph this side. That's okay too, that works. All right, so we got you graphed. Double check. I already did it in pencil, hopefully I didn't screw it up. -3 for my y-intercept, 2 for my slope, dashed line, and I graphed the less than side. Why would I graph the less than side? Because 0 and 0 would fail. If I plugged into 0, I'd have 0 is less than a -3, and that's false. So if you fail, you have to graph the other side, plus I kind of try to use common sense. Now the other equation I'm going to do in green, and I've already messed with it because x and y are on the same side, and I don't like that. So I move the 2x over to make it slope-intercept. So remember, you can do that just like any other regular equation. If you don't like the way it looks, you can solve it for slope-intercept form. Be careful, the symbol would flip if I divided by a negative. I don't. I do subtraction, but that's okay. That's not going to goof with the symbol. So I'm going to have y is greater than this line. So here we go. What is this line? Y-intercept is +2. The slope is -2, so I'd go over 1, down 2, over 1, down 2, over 1, down 2. You get the idea. Reverse it. It's a greater than, so again, it's also going to be a dashed set of lines here. And then I got to graph the greater than side. So what's the greater than side? Well, it'd be up here on this side. So basically, it's this side of the green line. So if I graph this side, oh, we now have an issue here. We have an area where they overlap. That is where your answers are. This is only okay for the green equation. This one's only okay for the red. This area fails them both. This where they overlap, that's where your actual answers are hanging out. So the reason I have you graph lightly to start is I want to give you a chance to darken in your answer where they overlap. So that way it's very obvious where your answers are hanging out. So, and if you want to kind of, trade on which angle you shade from, that will kind of help, I suppose. But again, you don't need to spend 1,000 years making sure it all gets blotted out. But there you go. That looks pretty good right there. Okay, that's your solutions to this system. That's where all of the quarter points work for both the first inequality and the second inequality. All it is you just graph 2 of them on one and then take your time. So you basically follow your 3 rules twice. So you have 6 things to do, more or less. Here we go. Let's try another one. Here we go. So we got some solid lines on this one. All right, here we go. So first one, we're going to make the first one red. So I've already, as you can see, I've already altered the second one to my liking. Y is greater than or equal to -x plus 5. So where is plus 5? 1, 2, 3, 4, 5. A slope of -x means 1 to the right and down 1. So here she goes. Down, 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 down. Solid line. So that's where it goes. This is what it looks like. This red pen is not doing too well for me here. Hang in there, red pen. We're almost done. Do a few more examples for me, please. I don't want to retire you yet. Come on. There you go. All right. So greater than. Where's the greater than side? Right there. I always look at the Y arrow. That kind of helps me out here. Okay, there's the greater than side. So nice and light like. I don't really have a choice. The pen's running out. All right, we got you. All right. Green one. As you can see, X and Y are on the same side. Nope, go away. So I move the X value over here. If it's negative, I add. I'm going to have y less than or equal to 3x minus 4. Where's my y-intercept? Y-intercept is -4. 1, 2, 3, 4. Slope is 3. 1 to the right, up 3. 1 to the right, up 3. 1 to the right, up 3. You get the idea. It's going to be a solid line. That's where it goes, and it goes there with the solid line. Do I have a straight edge device? I want to make at least one of my lines look nice. Okay, here we go. Making it look nice. Here we go. Here we go. Look at that guy. Okay, now we're less than y. So where's the less than side? Well, that's the greater than side. Here's the less than side. So hide this side right here. So the green shading is going to go right there. And then again, oh, that's where they overlap. There's where there's red and green. So don't darken it in too well because I do have a bonus surprise for you here. We're going to graph one more, and it's going to be blue. Okay, here we go. Bonus inequality. Let's graph where x is less than 1, 2, 3, 4. Yeah, let's do x is less than 4. Ooh, bringing it all together. So these are right here. Remember these ones? Here we go. So where does x, oops, sorry, stuff's in the way. Where does x equal 4? 1, 2, 3, 4. There it is. Okay. So we're going to have a dashed line going right up this way. Oh, man. Getting crowded in here, friends. There we go. And if it's less than 4, that means you would shade this side. So I'm going to kind of keep it light. You'll see why here in a second. There we go. Okay, now where do all three of them overlap? Well, there's red, green, and blue kind of right in this little triangle shape right there. Look at that. There you go. That's where all three of them overlap, and then there's a dashed line right there. So you can see how messy this gets by hand pretty quick. But yeah, there's the green line, so you got to stop there. There's the red line, so you got to stop there, and there's the blue line, so you got to stop there. So that would be your final answer. Oofta. That's where all of them are hanging out. So every single corner point in this little triangle right here works for all three equations. The first one, the second one, and the third one. And then if we wanted to get really messy with it, we could add another. You get the idea. You guys are fine at this point. So that's it. Just graph one equation at a time, put the line in the right spot, use the right type of line, shade the right side, and then these things get graphed before you know it. All right, see you in class.